This is the only video you need to watch if you want to understand list data structures. I'm Anjali, a software engineer at Microsoft with previous experience at Meta and Amazon, and my Instagram blew up because I can explain complex tech topics in extremely simple words. My philosophy is simple: if you can't explain it to a 5-year-old, you don't understand it yourself. List data structures are one of the most important foundations for coding interviews because every question that you're asked falls back to one core concept. How should you store the data so you can access it, update it, and delete it most efficiently? In this video, I'll explain these 3 data structures that you need to thoroughly understand. I'll talk about how to remember each one, basic operations you can do on each with a cheat sheet, real-world examples so it sticks, and lastly, a list of questions you need to solve immediately after watching this video so that you'll never forget the concept again. Let's get started. The first is array. Think of an array like a row of small containers. Each container has a number on it called the index, and inside each container you can store data. For example, I have these toys. The first one goes at index 0, the second one goes at index 1, and so on. As you can see, arrays store every item in order. This is great when you want to quickly access something by position. For example, if I want the toy at index 1, I can grab it directly because I know the address to it. But here's the catch. If I want to insert a new element in the middle, I can't squeeze it in. Instead, everything after it will need to be shifted one by one, so this is an expensive operation. Similarly, if I want to remove something in the middle, everything after it will have to shift so that there's no weird empty spots. This is why insertion and deletion is slower in arrays, but search is instantaneous. The second problem is arrays have a fixed size. So if you created an array of size 4, you can't just add another element in the end. If you want to increase the size, you'll have to create a brand new array. Similarly, if you want to access something that's outside the array, let's say you try to look for something at index 10, your computer is going to throw an error because there's nothing at that point. The size is limited to 5. This is called an out-of-bounds exception. Now that you understand it, here's your cheat sheet. In Java, you can create the array like this. String here represents what the array is made of. It can be a list of strings or integers or booleans, whatever you prefer. As you can see, this array is going to be of a fixed size 3. You will no longer be able to increase it after this. You can access the toy at index 0 by typing this. You can update the toy at index 1 by typing this. If you want to know the length of the array, this is what you use. And lastly, you can loop through all of the toys by using this. I have the entire cheat sheet for you in the description box, but this was super helpful for me because I just had to write 5 to 6 lines per data structure and just read it before every interview so that I knew the exact operations I can use per data structure when the time came. Now, we discussed the issue where arrays, especially in Java, are a fixed size. To overcome this issue, we can use an array list. An array list works exactly like an array, but the size is not fixed. Here is how you would initialize one. As you can see, there is no size mentioned. You can add toys to the array list by these commands, and you can remove them using this. You can also update this toy at a specific index by using this command. This is what you would use to delete it. As you can see, you can delete from the middle of an array list, no problem. But what happens behind the scenes is what we discussed earlier. That is, every element after the one you deleted has to shift up by 1 space. A real-world example here would be seats in a movie theater. They're fixed in a certain row. Another example would be, let's say you want the days of the week. You know the size is always going to be 7, so you can store it like this. Similarly, if you have a game board, let's say a tic-tac-toe, you know it's going to be 3 by 3 at all times. So these were all examples for arrays. A real-world example for an array list would be a shopping cart so that you can add as many items as you need. Another example is Instagram comments. You can keep adding them as needed. They're not a fixed size and you cannot determine the size early on. So that's all for arrays and array lists. Now let's talk about linked lists. A linked list also has a container known as node, but each container has 2 things. First is the data, and second is the address of the next container. So instead of everything sitting in a fixed row like an array, every container will connect to the next container. SpongeBob doesn't need to know where every toy is. It simply needs to know where the next toy is, which is the owl. So each of this container has its own data, which is the toy, and a pointer to the next toy. As you can see, the linked list stores items in order, but it doesn't use indices the way arrays do. In an array, if I wanted the item at index 2, I could simply retrieve it. But in a linked list, I'd have to start from the first one and keep going to the next one until I hit index 2. This is why searching and accessing something in a linked list is very slow. However, if you want to add or delete something, nothing has to be shifted because we have these little connectors. So if I want to remove the owl here, all I need to do is simply get rid of this container and have SpongeBob point to the duck instead. Instead of moving every toy after the owl, we simply change the pointer that SpongeBob pointed to. This is why insertion and deletion is very fast in linked list as long as you know what exactly you want to insert and delete. Another important thing to note is linked list doesn't have a fixed size. You can just keep adding stuff as long as you have memory. One question you may have is an array list can also insert and delete stuff in the middle, so why not just use that? Because you can also retrieve stuff faster in an array list. Well, the difference is what happens behind the scenes when you delete something from the middle. In a linked list, it was a one-step operation where it simply had to point to the next one. But in an array list, everything after that element has to be shifted up. Now that you understand it, here's your linked list cheat sheet. You can create a linked list by this command in Java. String here represents what the linked list is made of. It can be integers, booleans, or string like in this example. You can keep adding to the linked list by doing .add. You can also add something to the front of the linked list by doing add first. You can access something by doing .get and update something by doing .set. To delete, use .remove, and to find the size, use .size. This is how you would loop through a linked list. Again, the entire cheat sheet is in the description box. Java has a built-in linked list class, but most interviewers try to test you if you can create one from scratch. So all you'll have to do is make a container which is called a node. And every node should have some kind of data. In this example, it's a string, and a pointer pointing to the next node. So an example in this case would be you create all these new nodes and then make sure they point to one another as needed. A real-world example of a linked list would be your browser history. When you go from one page to next, each page can point to what it went after. Another example could be a music playlist. Each song can point to the next one. You can easily insert songs in between or remove songs from the queue. Lastly, you can also think of a train car. Every cart is connected to the next one. Now, this will help you clearly understand the theory, but until you get your hands dirty, this concept will never click. So what I need you to do is solve this exact list of problems in this exact sequence. This will make sure you truly understand arrays and linked lists. The first one you're going to start with is twosome. This will teach you how arrays store values by index and how to search through them. Next, you'll do these 5 easy array problems. I have provided all the links in the description box. Next up, we move on to linked lists. Before you start solving the LeetCode problems, try to create one by yourself. Here's a reference you can use if you need help. Next, you want to do these 6 easy linked list problems. They'll teach you how a linked list works, how to work with pointers, and how to combine or reverse linked lists. If you do them in these orders, you won't just memorize the theory, you'll actually get an understanding. Let me know if you found the video helpful and I can cover the rest of the data structures. Make sure you subscribe. Everything that I talked about is in the description box, and I'll see you in the next one.